Welcome back with maths classes by the winner answer. Today we are going to discuss class 10 topic, that is circle. In this lecture we are going to discuss basics of circle and then we come to the point of tangent here. So first of all, in a circle what we have required? In a circle, this fixed point name of this fixed point is known as center of a circle. Now next point, what is the radius? If we take any point on the boundary and this distance between the fixed point and a moving point is known as radius. So what we can say here, radius is a distance of a fixed point to the any point on the boundary of a circle is known as a radius of a circle. If we see another side, we are again drawing circle. We are taking here different shapes, different cases. If you see here, any line touches the circle at a single point. This point is known as point of contact, and this touching line is known as tangent of a circle. If you see here, if any line passes through a circle and it touches the circle at two different points, then this PQ is known as secant of a line. This is a line which passes through the circle and touches the circle at 2 points, then the inner part of the line segment is known as secant of a line. If we see here another case, if we join any 2 points on the boundary of a circle, say AB, then this AB is known as chord of a circle. So what we see here, if in a circle there is a fixed point, that is known as center of a circle. If we take any point on the boundary whose distance remains same from the fixed point, that is known as radius of a circle. If we draw a line, there are two possibilities. It may pass inside the circle, it may touch the circle outside. If it passes inside the circle and meets the circle at 2 points, then the inner part of the line is known as secant of a line. And if it touches the circle at a single point, then point is known as point of contact and the line is known as tangent to the circle. If we join any 2 points on the boundary of a circle, then it is known as chord of a circle. Now, how many tangents can we draw here at a single point and how many parallel tangents can be drawn to a circle? If you see from the figure, if you see here, we are taking here circle first. If you see here, this is one of the tangent. Parallel means like this. If we draw many cases of like this, lines parallel to given tangent, this is tangent we have taken here and we are drawing the lines parallel to it. If you see here, how many parallel tangents are there? It passes through the circle, it cuts at 2 points. This is known as secant. This is also secant. This is also secant. This is touching at single point, so it is also known as tangent. How many parallel tangent at a time? These are comes in pair here. So it means pair of parallel tangents can be done to a given circle. Another question, how many tangents can be drawn at a single point? We can see it from the given practical example. See here, we are taking here practical shape. If you see here, this is a triangle shape which is known as a circle in practical life. If we say this is a pen in a practical life, it behaves like a tangent here if you put on the bangle. So how many tangents at a point can be drawn? There is a single tangent is drawn at a point. How many tangents can be drawn to a circle? If you see here, if we keep on moving, tangent changes. It means how many tangents can we draw? We can draw infinite number of tangents to a circle. But at a single point, a single tangent is drawn. But how many parallel tangents are drawn? Here, pair of two tangents together we can draw here. Now we are going to discuss theorems of the chapter 10 class circle. Here one of the theorem is given by if we join a line segment to the center of a circle with a point of contact to the tangent. We want to prove this makes OP line makes 90 degree angle with the tangent here. Means angle between the radius and tangent of a circle is 90 degree. How can we prove it? Let's see. But before this, we need to remember one concept. The shortest distance between a line segment. If we see any object straight to us, then the minimum distance is known as perpendicular distance. So we are going to use this concept. If we see here, taking here 2, 3 points, taking Q, R, S, etc. points on tangent AB. Here Q, R, S, we are taking the points here. If we join them with O, if we get here OQ, OR, OS. These are the points we have taken on the tangent AB. If we see in figure, up to this point, we can see C, B, this point is given by E. If we see here, OQ is given by OC plus CQ, where OC is given by radius plus CQ. It means OQ is greater than radius. Means we can say here OP, result number first. Because if you see the diagram, OP is a line segment which reaches at point C up to radius, and above it, it is more than radius. If we see another, and we see here OR is given by OD plus DR, means radius plus DR. It means OR is also greater than radius of P. Result number 2. If we see for OS also, OS, it is also written as OE plus ES, where O is radius, because radius is the distance from center to the boundary of a circle, plus ES, means OS is also greater than radius OP. This is result number 3. If we goes on continue in the same way, what we observe here, OP is greater than radius, OR is also radius, OS is also more than radius. So what we observe here, we observe that OP is shortest distance. As we have discussed, shortest distance are always perpendicular distance. It means OP is perpendicular to tangent AB. So it proves our first theorem of chapter circle of class 10th. Now we are going to discuss second theorem of the chapter circle of class 10th. The theorem is length of tangents drawn to a circle from an external point are equal in length. If you see here, we have drawn a circle with center O. P is here an external point where tangents are drawn. First tangent is PA, second tangent is here PB. Here we have to show here these two lengths PA and PB are equal. If we see here, to prove any two lengths are equal, we need to prove any two shapes are congruent. But here there is no triangle. If you see here, to make the triangles we need some joining of line segment, means we need here construction. So in construction we are going to join OA, OB and OP like this. If we join them OA, OB and OP, as we have done the previous theorem, line segment joining the point of contact of tangent with circle to the center of circle is perpendicular to the radius. This is 90 degree, this is also 90. If you see here, there are two triangles now. In triangle OAP, first upper triangle, which is a right angle triangle, Second triangle OBP is again a right angle triangle. So our aim, that is to prove triangles are congruent. We get here triangles, so we are going to prove with the help of congruent concept. Solution we are doing here now. In right triangles OAP and OBP, if you see here, this angle say 1, this angle say number 2. Here, first of the component, angles are same. Why? Because each angle is 90 degree. So one of the component we get here, right angle. Second, if you see here, this is the common side. OP is common. We get one of the side now. If you see here, this length OA and OB are radius. OA is equal to OB. These are radius. If you see here, we are getting the concept of two sides with one angle. With two sides, one angle, we are having two options, SS and RHS. Here SS means angles come between the two sides. If you see here, these are the two sides we use here. Means angle should be this one. But angle is not this one. This is another one. So this rule is failed. Second option we are left in with RHS. Where R means right angle. We are already having. H means the side opposite to right angle. Means OP. Already there. S is the side which may be base, may be perpendicular. It is also there. So we are having the rule here. RHS rule. By RHS rule, these two triangles are congruent. So triangle OAP is congruent to triangle OBP. So by CPCT. Now what is the meaning of CPCT? C stands for corresponding, P stands for parts, again C stands for congruent, T stands for triangle. Means corresponding parts of congruent triangles are equal in measurement. Their angle as well as size also. So here we need here PA. If you see here, PA means third to second. Same here, third to second. So PA is equal to PB, which proves our requirement of the theorem. Means the length of tangent drawn from external point to a circle are always equal in length. Please like and share the videos more and more, so it will help the others also. Please subscribe the channel to get all the notification from Maths Classes channel from Devendra sir. Thank you.